Okay, welcome to Let's Get to the Marks. We're looking at A-level chemistry, organic analysis, NMR, and we're going on the physics and maths tutor website here, which is an awesome website for revision for your A-levels. Now, the website does have adverts, but it has so many resources. I'm going to A-level paper 2, organic 2, and I want to find NMR. Let's look at NMR spectroscopy here. So I click on this one down here on the list of questions by topic. It's also got revision cards and stuff. And then, oh, where am I? Here we go. Let's go to MCQ. That's multiple choice. And we're going to just crack through or smash through these multiple choice questions. Let's go. Okay, let's get into this. Question one. Again, we're here on the Physics and Maths Tutor site, MCQ. There's only four of these. Which statement does not support the suggestion that an unknown organic compound is, and then we have this diagram here of an organic compound. By the way, you can always pause the video and have a go before I go through the answers. And the link to these questions will be in the description. Pause. Just thought I'd say that. Right, let's go. So let's check out A. Does this support or not support this compound? Well, A says it has an integration ratio or trace of 233. Now, the integration trace tells us how many hydrogens are in each environment, or the ratio of hydrogens in each environment. And we can see here nice and clearly that we have a ratio of 3 to 3. So we've actually got exactly that ratio 233, so that does support it. So it's not looking like this doesn't support it. Also, there's three peaks, three different hydrogen environments. So we can see here we've got three different hydrogen environments. Okay, we've got a methyl, we've got two methyls, but they're both connected to different adjacents. So actually this is the wrong answer, because this does support that structure. Now let's look at the next one. Actually, we're going to go to C. Its infrared spectrum has an absorption of 1,735 centimeters. So let's check that out on the data booklet. So this first column here shows the wavelength of different groups. And if we go down to 1,680 to 1,750, that's where our 1,735 falls. We can see it's a carbonyl group. So the question is, did the compound in the question have a carbonyl group? And let's have a look. And yes, C does support the answer, because you can see there's a carbonyl group there, and that was represented by that infrared absorption. So yeah, that's not the answer either. We're looking for something that doesn't support the answer. So we're looking for something that isn't correct, essentially. So what we're looking at here is, what's the MR of this compound? We're looking at D now. And the MR of this compound is 88. If you add up all the carbons, hydrogens, and oxygens, you get 88. Now we're trying to see, is it 36% oxygen by mass? Well, there's two oxygens, that's 16 each, so that's 32 over 88. What is times 100? What does that equal? It equals 36%. So actually this does support that the amount of oxygen is 36% by mass. Now we want to do the hydrogen. Well, you can count up, there's 8 hydrogens there. There's 3, 2, and 3. Add them together, that's 8. Divide it by 88, the total MR, times 100. We can find that it's 9% hydrogen by mass. So again, D does go with that compound. So D is not the correct answer, because remember, we're looking for something that does not support this compound structure. So obviously now we know that B is the correct answer. Um, and why is that? Let's look at why B is correct. So it says that there are 3 peaks, but actually if you look at how many carbon atoms, there are 4 carbon atoms, and they're all completely different environments. Yes, carbon 1 and 4 are both methyl groups, but look what they're adjacent to. Carbon 1's adjacent to a carbonyl group, and methyl is adjacent to a CH2 group. So they are different environments. There are 4 carbon environments, not 3. So we wouldn't get 3 peaks. Okay, question 2. How many peaks are there in C13 NMR spectrum of 1,4-dimethylbenzene? First step, let's draw it out. So I want 2 methyl groups, one on either end of the benzene. And now we've got to count up how many different environments are there, and that equals the number of peaks. So the 2 methyls are one environment. Then I've got these 2 corners, and these 2 corners are all symmetrical. They're all adjacent to the same things. So that's the second environment. And then these 2 at the ends is the third environment. So there's going to be 3 peaks here, because those are the 3 different environments. Awesome. Let's move on. Okay, how many peaks does this compound have in its C13 spectrum? Okay, is it 5, 6, 7, or 8? So let's take a closer look. Well, if we count out the different peaks, we could say, look, there's these two look at first like they're symmetrical, like they're identical. These guys all look identical, like they're both ones and they're both twos. But actually, look what they're connected to. The C2 at the top is connected to a sulfur, whereas the C2 at the bottom is not connected to a sulfur. So they actually are not identical groups. So actually what we find, because of that sulfur atom at the top, every single carbon environment is different because what's adjacent to it is different. So we actually have 8 different carbon environments. You can count them all along here. None of these are identical. All of them have different groups on their left or right attached to each of those carbons. So the answer, of course, for question 3 is D. There are 8 different carbon environments, and you'd get 8 different peaks on the spectrum, on the CNMR spectrum. Okay, let's look at question 4. Which amine has only 3 peaks in its proton NMR spectrum? Of course, proton means hydrogen NMR, H1 NMR spectrum. So what we're going to need to do is draw each of these out, count up how many different hydrogen environments there are, and see which one has 3 peaks. Of course, you could pause the video and have a go. All right, let's look at methylamine. So it's a methyl group attached to NH2, an amine group. How many different hydrogen environments? There's 2 different hydrogen environments. We've got the methyl group and the amine group. So this would get 2 peaks. All right, let's look at trimethylamine. Trimethylamine, of course, is what it says on the tin. It's a nitrogen atom with 3 methyl groups attached. Okay, I'm not going to bother drawing the hydrogens because it's all a little bit close here, but you can just imagine there's a hydrogen on the end of each of these. And those are all identical because they're all adjacent to the same nitrogen. So they're identical groups. So you're actually going to get 1 peak with this because the 3 methyl groups are all identical, or what they're attached to, their environment is identical. So these hydrogen groups are all identical. 1 peak. Oh, I was getting a bit peak. Yeah, okay. Moving on. Right. The other possibilities are C and D, but I'm going to go straight to D first, obviously, giving you the obvious answer that C is the correct answer. So let's draw out proparlamine. So prop means it's got 3 carbons and we've got an NH2 at the end, which is the amine part. Okay. And all we need to do is count this up and see how many different peaks this would have. How many different hydrogen environments? At first glance, we might see the 2CH2 groups and think, oh, those 2CH2 groups are the same, so they'll be involved in the same peak. But of course they won't, because the first CH2 group is attached to this methyl group at the end, and the second CH2 group is attached to the amine group and a CH2 on its left. So they are different hydrogen environments. What's adjacent to them are different. So this has 4 different hydrogen peaks. So the correct answer here is obviously going to be C, and we're going to draw out diethyl amine. So what we've got is an amine group with an ethyl on either side here. And if we count up the different hydrogen environments, we've got 2 identical methyl groups. They're both attached to CH2 on their side of them. And then we have 2 CH2 groups, which are identical because they're attached to the NH in the middle, and the NH is its own hydrogen environments. The answer is C. There are 3 peaks on a proton NMR spectrum. All right, guys, that was all the multiple choice questions on the physics and maths tutor for AQA chemistry. Let's get to the marks.
You're still here? It's over.